Indian Space Research Organisation. The Indian Space Research Organisation, ISRO, is the space agency of the Government of India headquartered in the city of Bengaluru. Its vision is to harness space technology for national development while pursuing space science research and planetary exploration. The Indian National Committee for Space Research, INCOSPAR, was established in the tenure of Jawaharlal Nehru under the Department of Atomic Energy, DE, in 1962, with the urging of scientist Vikram Sarabhai recognizing the need in space research. INCOSPAR grew and became ISRO in 1969, also under the DE. In 1972, Government of India set up a Space Commission and the Department of Space DOS, bringing ISRO under the DOS. The establishment of ISRO thus institutionalized space research activities in India. It is managed by the DOS, which reports to the Prime Minister of India. ISRO built India's first satellite, Aryabhata, which was launched by the Soviet Union on 19 April 1975. It was named after the mathematician Aryabhata. In 1980, Rohini became the first satellite to be placed in orbit by an Indian-made launch vehicle, PSLV-3. ISRO subsequently developed two other rockets, the Polar Satellite Launch Vehicle (PSLV), for launching satellites into polar orbits and the Geosynchronous Satellite Launch Vehicle (GSLV), for PLA. Sing satellites into geostationary orbits. These rockets have launched numerous communications satellites and Earth observation satellites. Satellite navigation systems like Gagan and IRNSS have been deployed. In January 2014, ISRO used an indigenous cryogenic engine in a GSLV-D5 launch of the GSAT-14. ISRO sent a lunar orbiter, Chandrayaan-1, on the 22nd of October 2008 and a Mars orbiter mission, on the 5th of November 2013, which entered Mars orbit on the 24th of September 2014, making India the first nation to succeed on its maiden attempt to Mars, and ISRO the fourth space agency in the world as well as the first space agency in Asia to reach Mars orbit. On the 18th of June 2016, ISRO launched 20 satellites in a single vehicle, and on the 15th of February 2017, ISRO launched 104 satellites in a single RO. CKET PSLV C-37, a world record. ISRO launched its heaviest rocket, Geosynchronous Satellite Launch Vehicle Mark III, GSLV Mk3, on the 5th of June 2017 and placed a communications satellite GSAT-19 in orbit. With this launch, ISRO became capable of launching 4-ton heavy satellites into GTO. On the 22nd of July 2019, ISRO launched its second lunar mission Chandrayaan-2, which consists of an orbiter, lander and rover, to study the distribution of lunar water and lunar geology. Future plans include development of the Unified Launch Vehicle, Small Satellite Launch Vehicle, development of a reusable launch vehicle, human spaceflight, a space station, interplanetary probes, and a solar spacecraft mission. Modern space research in India is traced to the 1920s, when scientist S.K. Mitra conducted a series of experiments leading to the sounding of the ionosphere by applying ground-based radio odds in Kolkata. Later, Indian scientists like C.V. Raman and Meghnad Saha contributed to scientific principles applicable in space sciences. However, it was the period after 1945 that saw important developments being made in coordinated space research in India. Organized space research in India was spearheaded by two scientists, Vikram Sarabhai, founder of the Physical Research Laboratory at Ahmedabad, and Homi Bhabha, who established the Tata Institute of Fundamental Research in 1945. Engineers were drawn from the Indian ordnance factories on deputation to harness their knowledge of propellants and advanced metallurgy, as the ordnance factories were the only organization specializing in these technologies at that time. Initial experiments in space sciences included the study of cosmic radiation, high-altitude and airborne testing, deep underground experimentation at the Kolar mines, one of the deepest mining sites in the world, and studies of the upper atmosphere. Studies were carried out at research laboratories, universities, and independent locations. In 1950, the Department of Atomic Energy was founded with Bhabha as its secretary. The department provided funding for space research throughout India. During this time, tests continued on aspects of meteorology and the Earth's magnetic field, a topic that was being studied in India since the establishment of the observatory at Colaba in 1823. In 1954, the Uttar Pradesh State Observatory was established at the foothills of the Himalayas. The Rangpur Observatory was set up in 1957 at Osmania University, Hyderabad. Space research was further encouraged by the Government of India. In 1957, the Soviet Union launched Sputnik 1 and opened up possibilities for the rest of the world to conduct a space launch. The Indian National Committee for Space Research, INCOSPAR, was set up in 1962 by the efforts of India's first Prime Minister Jawaharlal Nehru. The prime objective of ISRO is to use space technology in its application to various goals and objectives, national tasks. The Indian space program was driven by the vision of Vikram Sarabhai, considered the father of the Indian space program. India's economic progress has made its space program more visible and active as the country aims for greater self-reliance in space technology. In 2008, India launched as many as 11 satellites, including 9 foreign, and went on to become the first nation to launch 10 satellites on one rocket. ISRO has put into operation two major satellite systems, the Indian National Satellites (INSAT) for communication services, and the Indian Remit E-Sensing Program (IRS) satellites for management of natural resources. In July 2012, Abdul Kalam said that research was being done by ISRO and DRDO for developing cost reduction technologies for access to space. During the 1960s and 1970s, India initiated its own launch vehicle program owing to geopolitical and economic considerations. In the 1960s to 1970s, the country developed a sounding rocket program, and by the 1980s, research had yielded the Satellite Launch Vehicle 3 and the more advanced Augman. TED Satellite Launch Vehicle, ASLV, complete with operational supporting infrastructure. ISRO further applied its energies to the advancement of launch vehicle technology, resulting in the creation of the successful PSLV and GSLV vehicles. The Satellite Launch Vehicle, SLV or SLV-3, was a four-stage solid propellant light launcher. It was intended to reach a height of 500 kilometers and carry a payload of 40 kilograms. Its first launch took place in 1979 with two more in each subsequent year, and the final launch in 1983. Only two of its four test flights were successful. The Augmented Satellite Launch Vehicle, ASLV, was a five-stage solid propellant rocket with the capability of placing a 150-kilogram satellite into low Earth orbit. Prime Minister of India Narendra Modi announced in his Independence Day address of August 15, 2018 that India will send astronauts into space by 2022 on the new Gaganyaan spacecraft. After the announcement, ISRO Chairman, K.Sivan, said ISRO has developed most of the technologies needed, such as crew module and crew escape system, and that the project would cost less than Rs 10,000 crore and would include sending at least 3 Indians to space, 300 to 400 kilometers above in a spacecraft for at least 7 days using a GSLV Mk3 launch vehicle. The chance of a female being a member of the first crew is very high, according to the Scientific Secretary to the Indian Chairman, R. Maheshwaran. Chandrayaan-2 is India's second mission to the Moon, which includes an orbiter and lander rover module. Chandrayaan-2 was launched on a Geosynchronous Satellite Launch Vehicle Mark III (GSLV MKIII) on July 22, 2019 at 2:43 p.m. IST. It is the first mission meant to explore the little-explored lunar South Pole. The main objective of the Chandrayaan-2 mission is to demonstrate ISRO's ability to soft land on the lunar surface and operate a robotic rover on the surface. Some of its scientific aims are to conduct studies of lunar topography, mineralogy, elemental abundance, the lunar exosphere, and signatures of hydroxyl and water ice. The Vikram lander, carrying the Pragyan rover, was scheduled to land on the near side of the Moon, in a south polar region at a latitude of about 70 degrees south at approximately 1:50 a.m. on the 7th of September 2019. However, at about 1:52 a.m. IST, the lander deviated from its intended trajectory at around 2.1 kilometers from landing and communication was lost. ISRO plans to launch a number of Earth observation satellites in the near future. It will also undertake the development of new launch vehicles, a crewed orbital vehicle, Gaganyaan, a space station and probes to Mars, Venus and near-Earth objects. ISRO plans to follow up with Mars Orbiter Mission 2, and is assessing missions to Venus, the Sun, and near-Earth objects such as asteroids and comets. The next Mars mission, Mars Orbiter Mission 2, also called Mangalyaan-2, will be launched in 2024. It will have a less elliptical orbit around Mars and could weigh 7 times more than the first mission. This orbiter mission will facilitate the community to address several open science problems. The science payload of the planned satellite is estimated at no more than 100 kilograms. ISRO plans to carry out a mission to the Sun by the year 2020. The probe is named Aditya-1, and will have a mass of about 400 kilograms. It is the first Indian space-based solar coronagraph to study the corona in visible and near IR bands. Launch of the Aditya mission was planned during the heightened solar activity period in 2012 but was postponed to 2021 due to the extensive work involved in the fabrication and other technical aspects. The main objective of the mission is to study coronal mass ejections, CMEs, their properties, the structure and evolution of their magnetic fields for example, and consequently constrain parameters that affect space weather. ISRO is in the process of conducting conceptual studies to send a spacecraft to Jupiter or Venus. The ideal launch window to send a spacecraft to Jupiter occurs every 33 months. If the mission to Jupiter is launched, a flyby of Venus would be required. ISRO is assessing an orbiter mission to Venus called SHUKRAYAAN-1, that could launch as early as 2023 to study its atmosphere. Some budget has been allocated to perform preliminary studies as part of 2017-2018 Indian budget under Space Sciences, and solicitations for potential instruments were REQ. Used it in 2017 and in 2018. Besides the Chandrayaan-2 lunar mission, ISRO is studying the potential for a joint lunar mission with Japan's Aerospace Exploration Agency, JAXA, to explore the polar regions of the Moon for water as Chandrayaan-3, that would be launched by 2024. Small Satellite Launch Vehicle or SSLV is in development for the commercial launch of small satellites with a payload of 500 kilograms to low Earth orbit. SSLV would be a four-staged vehicle with 3 solid propellant-based stages and a velocity trimming module. The maiden flight is expected in July 2019 from Satish Dhawan Space Center. As a first step towards realizing a 2-stage to-orbit TSTO, fully reusable launch vehicle, a series of technology demonstration missions have been conceived. For this purpose, the Winged Reusable Launch Vehicle Technology Demonstrator, RLVTD, has been configured. ISRO has opened Space Technology Incubation Centers (STIC) at premier technical universities in India which will incubate startups to build applications and products in tandem with the industry. And would be used for future space missions. The STIC will bring the industry, academia and ISRO under one umbrella to contribute towards research and development (R&D) initiatives relevant to the Indian space program. STICs are at the National Institute of Technology, Agartala serving for East Region, National Institute of Technology, Jalandhar for the North Region, and the National Institute of Technology, Tiruchirappalli for the South Region of India. In India, electromagnetic spectrum, being a scarce resource for wireless communication, is auctioned by the Government of India to telecom companies for use. As an example of its value, in 2010, 20 MHz of 3G spectrum was auctioned for 677 billion rupees, $9.8 billion United States dollars. This part of the spectrum is allocated for terrestrial communication, cell phones. However, in January 2005, Antrix Corporation, commercial arm of ISRO, signed an agreement with Devas Multimedia, a private company formed by former ISRO employees and venture capitalists from the U.S., for lease of SB and transponders, amounting to 70 MHz of spectrum, on two ISRO satellites, GSAT-6 and GSAT-6A, for a price of 14 billion rupees (200 million United States dollars), to be paid over a period of 12 years. The spectrum used in these satellites, 2,500 MHz and above, is allocated by the International Telecommunication Union specifically for satellite-based communication in India. Hypothetically, if the spectrum allocation is changed for utilization for terrestrial transmission, and if this 70 MHz of spectrum were sold at the 2010 auction price of the 3G spectrum, its value would have been over 2,000 billion rupees (29 billion United States dollars). This was a hypothetical situation. However, the Controller and Auditor General of India considered this hypothetical situation and estimated the difference between the prices as a loss to the Indian government. There were lapses on implementing Government of India procedures. Antrix, ISRO had allocated the capacity of the above two satellites to Devas Multimedia on an exclusive basis, while rules said it should always be non-exclusive. The cabinet was misinformed in November 2005 that several service providers were interested in using satellite capacity, while the Devas deal was already signed. Also, the Space Commission was kept in the dark while taking approval for the second satellite. ISRO committed to spending 7.66 billion rupees (110 million United States dollars) of public money on building, launching, and operating two satellites that were leased out for Devas. In late 2009, some ISRO insiders exposed information about the Devas Antrix deal, and the ensuing investigations resulted in the deal being annulled. G. Madhavan Nair, ISRO chairperson when the agreement was signed, was barred from holding any post under the Department of Space. Some former scientists were found guilty of acts of commission, or acts of omission. Devas and Deutsche Telekom demanded 2 billion United States dollars and 1 billion United States dollars, respectively, in damages. Government of India's Department of Revenue and Ministry of Corporate Affairs initiated an inquiry into Devas shareholding. The Central Bureau of Investigation concluded investigations into the Antrix Devas scam and registered a case against the accused in the Antrix Devas deal under Section 120B, besides Section 420 of IPC and Section 13(2), read with 13(1)(d) of PC Act, 1988 on the 18th of March 2015 against the then executive Director of Antrix Corporation, two officials of USA-based company, Bangalore-based private multimedia company, and other unknown officials of Antrix Corporation or Department of Space. Devas Multimedia started arbitration proceedings against Antrix in June 2011. In September 2015, the International Court of Arbitration of the International Chamber of Commerce ruled in favor of Devas, and directed Antrix to pay 672 million United States dollars (rupees 44.35 billion) in damages to Devas. Antrix opposed the Devas plea for tribunal award in the Delhi High Court. In September 2019, Pallav Bagla, a journalist covering ISRO for NDTV, was discovered to be selling ISRO images captured during his coverage of the organization over several years. Earlier, Bagla was also found misbehaving with senior scientists during the ISRO press conference after the Chandrayaan-2 project team lost contact with the Vikram lander. Thanks for watching. Subscribe to Footprints for more videos.